Programme 2: Energy System Integration. Investing in clean energy production and storage has never been more important. As we accelerate towards a net zero energy industry, we must create a fully integrated energy system. Let's take a closer look at the game-changing projects and technologies which can help us achieve a sustainable energy future. Energy System Integration. Ready in 12 months. Technology 1. Waterwhelm Limited. Waste heat power desalination for hydrogen production. To meet the UK's aim of 5 gigawatts of low-carbon hydrogen by 2030 and up to 35% of the UK's final energy demand by 2050, vast quantities of water will be required to produce green and blue hydrogen. Existing potable water supplies cannot meet the future demand required by coastal and offshore hydrogen production facilities. The most sustainable option will be to use seawater. However, this adds cost as seawater must be desalinated and purified prior to use. Currently, about 10% of hydrogen production costs are attributed to desalination. If we can reduce this cost, we reduce the overall cost of producing low-carbon hydrogen. Waterwhelm has developed a patent-pending forward osmosis technology powered by waste heat. This technology utilises natural osmotic pressure to draw water across a semi-permeable membrane. Waste heat is used to separate the water from the draw solution and is in abundance across many industrial processes. Inherent waste heat is also associated with green and blue hydrogen. Waterwhelm's technology can be utilised to reduce the electricity consumption of desalination by up to 80%. Global hydrogen ambitions will only be achieved if seawater can be utilised. This technology can provide low-cost and sustainable access to desalinated water. Energy System Integration Technology on the horizon. Technology 2. Energy Hubs. The UK currently produces 8.5 gigawatts of wind power with plans to increase the output to 30 gigawatts by 2030 and 80 gigawatts by 2050. To achieve this goal, multiple energy hubs in strategic locations around the UKCS will be needed. Energy hubs will combine operation, production, storage and transport. These are cornerstones of an integrated energy system and essential for the transition to net zero. The hubs will produce clean energy by connecting renewable energy sources such as wind, tidal and hydrogen. They will play a key role in decarbonising ongoing oil and gas operations, creating a circular economy by repurposing existing infrastructure where possible, producing hydrogen at scale, and providing alternative fuels for vehicles and marine vessels. Creating clean energy hubs across the UK will contribute 60% towards the country's overall net zero targets by 2050. They will provide 5% of the UK's low-carbon energy by 2030 and 12% by 2050. With a potential gross value add to the UK economy of between £31 and £220 billion. Energy System Integration Technology on the horizon. Technology 3. CO2 Circulaire B.V. Smart DAC. Most carbon capture techniques focus on removing emissions at source to prevent the harmful gases reaching the atmosphere. These techniques work well for heavy industry like iron and steel, but these industries only account for 30% of total emissions. The other 70% comes from distributed sources like cars, aviation, shipping and agriculture, where it is impossible to capture carbon at source. Using membrane gas absorption and electrolysis regeneration, the smart DAC system separates the CO2 from the air, creating a continuous absorption regeneration cycle. The CO2 captured can be reused as a carbon source for sustainable chemicals and synthetic fuels to replace fossil fuels and create a short carbon cycle, or stored to remove CO2 from the atmosphere permanently. Using wind circulation to push air through the system and being powered using green energy, Smart DAC is a zero-emissions solution for CO2 capture. With an estimated 10 gigatons of CO2 removal per year required by 2050, potentially doubling to 20 gigatons by the end of the century, direct air capture technologies will play a key role in delivering net zero objectives through mitigating CO2 emissions. The scalability and sustainability of the Smart DAC system makes it an affordable solution to small, medium and large-scale capture of CO2. Innovation is essential to delivering an integrated energy system that will realise our net zero future. Hello, future.